Hey there, and welcome. Have you ever stopped to think about the secret chemistry that's happening all around us? I mean, it's in the food we eat, the soap we use. It's everywhere. Today, we're going to pull back the curtain on these fundamental forces, acids, bases, and the salts they make. It's going to be awesome.
Okay, let's start with something we've all felt. You know that feeling? You've had a huge, delicious meal, and now you've got that painful, burning acidity. Ugh. So, what's the move? Do you reach for some sour lemon juice or maybe a solution of baking soda? It seems like a simple question, right? But the answer is pure chemistry. And yeah, spoiler alert, it's the baking soda. And I promise, by the time we're done here, you'll understand exactly why.
All right, so to figure out that whole stomach acid problem, we've got to meet the two main characters in our story today, acids and bases. Think of them as total opposites, and, their unique personalities are the key to understanding, well, pretty much everything from cooking to cleaning.
So, how do we even know what's what? Well, believe it or not, a lot of the time we can just use our senses. Acids, right? Think about the citric acid in lemon juice or the stuff in vinegar. They have that distinct sour taste. Bases, on the other hand, are totally different. They're bitter and can feel kind of slippery or soapy. You know that unique taste of baking soda? Yep, that is a classic base right there.
But, okay, obviously chemists aren't in the lab just tasting everything. I mean, that would be a terrible, terrible idea. So, how do they tell acids and bases apart without, poisoning themselves? They've got a clever trick up their sleeve. They use these special things called indicators, which basically change color to give away a chemical's true identity.
And the most famous one of all, the one you probably remember from school, is litmus paper. It's such a classic test. So here's how it works. You dip a little strip of blue litmus paper into something acidic, and boom, it instantly turns red. A good way to remember it is red for acid. Simple as that.
And you guessed it, for bases, it's the complete opposite. You take a piece of red litmus paper this time, dip it into a basic solution, sometimes called an alkaline solution, and it'll turn blue. So that's the main takeaway, super simple. Acids turn litmus red, bases turn it blue. It's like a reliable, color-coded secret decoder. And what's so cool about this is that indicators aren't just for labs. They're literally everywhere. Have you ever spilled some curry on a shirt and then tried to wash it with soap? You might have seen the yellow stain turn this weird reddish-brown color. That's the turmeric in the curry acting as a natural indicator. It's reacting to the base in the soap. There are even olfactory indicators, things like onion or clove oil, that actually change their smell depending on if they're in an acid or a base. How wild is that? Okay, so we know who our players are. We know how to spot them. Now, let's see what happens when they actually come face to face. This is where the real action is, folks. A chemical showdown with some seriously fascinating results. All right, this right here is probably the most important reaction we're going to talk about. It's called neutralization. And it's exactly what it sounds like. When an acid and a base get together, they neutralize each other. They basically cancel each other out. And what you're left with are two brand new, totally neutral things, a salt and plain old water. And this is the secret behind our stomachache remedy. The baking soda is a base, and it neutralizes that extra stomach acid. See, it all connects. But acids have a few more tricks up their sleeve. Check this out. When an acid gets in contact with certain metals, like zinc for instance, it kicks off a reaction that releases a gas, and that gas is hydrogen, the lightest, most abundant element in the entire universe. But, how can we be sure it's hydrogen? Well, with a really fun little experiment called the pop test. Here's what you do. You get that reaction going, and you capture the gas that's being produced in soap bubbles. Then, you bring a burning candle or a lit splint close to one of those bubbles and pop! You get this awesome little popping sound. That sound is the hydrogen combusting, and it's the definitive proof that you've made hydrogen gas. It's a test you can literally see and hear. So, we know that some acids are super strong, and others are pretty weak. Same with bases. But how do we actually measure that strength? How do we keep score? Well, in chemistry, that scorecard has a name. It's the pH scale. The pH scale is super straightforward. It runs from 0 all the way up to 14. Right in the middle, it's 7. That's perfectly neutral. Think pure water. Now, anything below 7 is an acid, and the lower the number, the stronger it is. So a 1 is way more acidic than a 6. And anything above 7 is a base, or alkaline, with 14 being the absolute strongest. It's just a simple, elegant way to put a number on chemical strength.
Okay, so let's look at this number. 5.5. Why should you care about 5.5? Well, this number is actually incredibly important for your teeth. This is the critical pH level inside your mouth. The moment the pH in your mouth drops below 5.5, the acid starts to attack and corrode your tooth enamel, which, by the way, is the hardest substance in your entire body. And that right there is how tooth decay gets started.
You know, once you start looking at the world through this lens, thinking about acids, bases, and pH, you start to see it absolutely everywhere. This isn't just some stuff that happens in a lab. These principles are running in the background of our daily lives, from what's happening inside our bodies to events that literally shaped our history.
So let's bring it back to our hero of the day, baking soda. We already know it's a great antacid, but it's also a star player in baking powder. In the oven, it reacts to create carbon dioxide gas, and all those tiny bubbles are what make your cakes so soft and spongy. And get this, it's even used in some types of fire extinguishers. What a seriously versatile chemical, right? And what about those salts we mentioned, the things made during a neutralization reaction? Well, the one we all know is sodium chloride, or, table salt. But it's so much more than just something you sprinkle on your food. Salt has been so incredibly vital to human civilization that it has literally shaped economies and politics. It even became this powerful symbol of freedom during Mahatma Gandhi's famous Salt March in India. Just amazing.
Here's another incredible salt for you: calcium sulfate, which most of us know as plaster of Paris. It starts as this fine powder, but when you mix it with water, a chemical reaction happens that turns it into a hard, solid mass. And that property is exactly what makes it perfect for doctors to create casts that hold broken bones in place so they can heal properly. It's chemistry in action, helping us mend.
So you see, this stuff isn't just a chapter in a textbook. It's the reason a simple solution of baking soda can calm your stomach. It's why we use toothpaste to fight off decay. It's how a basic substance like salt can change the entire course of history. Chemistry is happening constantly, all around you, from your own body to the soil in your backyard. So, the only question left is, where are you going to spot it next?